So here we're going to look at the vector valued function r of t is t squared t cubed, and our goal is to eventually find a unit normal vector. And sadly, we do not have a shortcut method for this like we did in 2-space. So we're going to be forced to go through the process. So we start with r prime of t, which is 1, 2t, 3t squared. What is the magnitude of r prime of t? Square root of the dot product with itself. That is 1 plus 4t squared plus 9t to the fourth. And then what is big T of t? The unit tangent vector is velocity r prime of t divided by the speed. Magnitude of r prime of t. So what do we get? 1 over the square root of 1 plus 4t squared plus 9t to the fourth, comma 2t over the square root of 1 plus 4t squared plus 9t to the fourth, comma 3t squared over the square root of 1 plus 4t squared plus 9t to the fourth. So we get t of t. And while we're at it, let's go ahead and find t of 1. What is t of 1? 1 over root 14. 2 over root 14. 3 over root 14. So this isn't so bad. This isn't so bad. But if I want to get n of t, how do I find n of t? N of t is t prime of t divided by the magnitude of t prime of t, which means we will need to take the derivative of this slot, and this slot. So you could imagine the calculus is going to get rather challenging, certainly tedious. So to find t prime of t, I've got to take the derivative of each piece. How about the derivative of the first piece? The derivative of the first piece would be the derivative of 1 plus 4t squared plus 9t to the fourth to the negative 1/2 power, which would be negative 1/2 times 1 plus 4t squared plus 9t to the fourth to the negative 3/2 times the derivative of the inside, which is what? Which is 8t plus 36t cubed Let's try to clean this up if we can. What do I have upstairs? Negative 1/2 of 4t is negative 4t. Negative 1/2 of 36, negative 18 t cubed over that whole thing to the 3/2 power over 1 plus 4t squared plus 9t to the fourth to the 3/2 power. So that wasn't so bad, but then the next two are going to be worse because they're going to require us to use the quotient rule. So let's at least write it down. What is the derivative with respect to t of 2t over the square root of 1 plus 4t squared plus 9t to the fourth? Let's use an app to do this derivative for us. So let's take a look. Going to a Wolfram alpha, the derivative with respect to t of 2t over the square root of 1 plus 4t squared plus 9t to the fourth is 2 minus 18 to the fourth. I'll probably write that as negative 18 to the t to the fourth plus 2 over the same thing, 1 plus 4t squared plus 9t to the fourth to the 3/2, being consistent with how I wrote in the other problem. 1 plus 4t squared plus 9t to the fourth to the 3/2. So this is how I'm going to choose to write it. Negative 18t to the fourth plus 2 and 1 plus 4t squared plus 9t to the fourth to the 3/2 power. And then I also have to do the last derivative there. What is the derivative with respect to t of 3t squared over the square root of 1 plus 4t squared plus 9t to the fourth? Again, another job for an app. So let's jump back to Wolfram Alpha and see what we get here. So the derivative of 3t squared that I want upstairs, the derivative of 3t squared over the square root of 1 plus 4t squared plus 9t to the fourth. What does that give me? Gives me this. And how am I going to write that? How about 12t cubed plus 6t over that same thing to the 3/2 power. 1 plus 4t squared plus 9t to the fourth, all raised to the 3/2 power. So we started with t of t. We have the derivative of the first slot, the derivative of the second slot, and the derivative of the third slot, which will give me t prime of t. So let's go ahead and collect all of that stuff. So here's what t prime of t is. But I need the magnitude of t prime of t. So that is going to be the square root of t prime dot t prime. Which is going to be something, which is going to be the square root of negative 4t minus 8t cubed squared all over that stuff to the third power. Plus negative 18t to the fourth plus 2 over all that stuff squared over all that stuff to the third power. Plus 12t cubed plus 6t squared over all that stuff to the third power. So you could imagine the algebra is awful. But we have bots to help us with this, so let's go ahead and take a look. Which will be some kind of a square root thing on the top all over that thing to the 3/2 power. So what is that stuff on the top? You'll notice I've asked it to do that negative 4t plus 18t cubed squared plus negative 18t to the fourth plus 2 squared plus 12t cubed plus 6t squared. And that's where it is. We're going to look for some kind of a simplified form, and there we go. 324t to the eighth plus 468t to the sixth plus 2/16 t to the fourth plus 52t squared. Even with technology, this is pretty miserable. So that is the magnitude of t prime of t. And remember, we need to get n of t, which is t prime of t divided by the magnitude of t prime of t. So let's collect what we have there. So n of t is t prime of t divided by the magnitude of t prime of t. And you'll notice, finally, something nice in algebra, the bottoms essentially divide out. So it's all of this on top divided by all of that on the bottom. So that my n of t is simply going to be negative 4t minus 18t cubed, negative 18t to the fourth plus 2, 12t cubed plus 6t over that ugly square root thing on the bottom, which is 324t to the eighth plus 468t to the sixth plus 2/16t to the fourth plus 52t squared plus 4. So of course, what do I want to do now? I want to figure out what n of 1 is. So we get this lovely looking thing, negative 22, negative 16, 18, all over 1064. So let's reduce that fraction, see what we get. Of course, that's square root 1064 before we reduce. Simplifying that radical, that's 4 times 266 is 1064. Root 4 is 2, so we're here, which will indeed make that relatively easy to reduce. So what is that going to give us? And after all that work, we have n of 1 is negative 11 over root 266, negative 8 over root 266, and 9 over root 266. We want to visualize this. We want to see it if we can. T of 1, way back when, was 1 over root 14, 2 over root 14, 3 over root 14. And R of 1, what was our starting point? R of 1, it was t squared, t cubed, so R of 1 is just 1, 1, 1. So we should be able to see the graph as well as t of 1 and n of 1. So let's see if that will work. So you'll notice I have t squared, t cubed. There it is at the point 1, 1. And then I put in t of 1. That is my red vector. My t of 1 is 1 over root 14, 2 over root 14, 3 over root 14. Now let's see if n of 1 will be what we expect it to be. That would be nice if that happens. Let's see if that's the case. So we're going to go ahead and we're going to add another vector, which is negative 11 over the square root of 266, negative 8 over the square root of 266, and 9 over the square root of 266. We can make that black. We're starting at the point 1, 1, 1 again. Does this look like the unit normal vector? Can we believe that the red and the black are orthogonal? Obviously, you've got to look at it from a certain perspective, right? If we're looking at it straight down, certainly not. But in the 3D world, if we look at it just the right way, we can convince ourselves that those two vectors are orthogonal. And indeed, the black vector n is on the concave side of the curve. Very challenging problem, used a lot of technology, but we got there.